Okay, so here's a warm-up for the second quiz. It's going to have conversions and percent yield, and so we're going to start with a percent yield problem. So this one is a problem that goes together like this. It's going to eventually ask you for the percent yield, so you know you need the actual yield over the theoretical yield. So the actual yield is how much you actually made in the lab. And so here it told us that we produce this much. Every time you see this word, you know that this is the actual yield. So this number is going to be on top, 4.2 grams. That's the product that we are interested in. We're interested in this product only. Do you see how NAF is here and NAF is right here? It's telling us in the original problem, letter A, that we are starting with this much. This is what we're starting with. So HF is the ingredient that we're interested in. That means that we don't really care about this guy, or this guy. These are the only two numbers that we are interested in. This is what we're starting with. Well, not this number, but we're starting with this number, and we're going to end with this product. This is our goal over here. Okay, so you're going to start with what you have, 0.57 moles, 0.57 moles of HF, like this. We're already in moles, so that means that you can go ahead and use the numbers from our recipe. If you are using the numbers from the recipe, they must be in the same fraction, and you only use them once. Okay, so we are trying to get rid of HF, so the number 8 is going to go on the bottom because we already know everything about HF, but we want to know information about NAF, so that number goes on top. Those are the two numbers that I circled earlier. So these are the numbers that are straight from our recipe. They have to be in the same fraction, and you use those numbers exactly once. The question asks for grams, so we have to go one more step. So for every 1 mole of this compound, it weighs how much? So you're going to take sodium, add fluorine, and I believe it's going to be 22.99 plus 19 is 41.99. So if you do the math here, so you type it into your calculator, I believe you are going to get 5.98 grams of NAF. So remember, think about what this is saying. It's saying that if we start with this amount, then we should end with this amount. So this is our theoretical yield. The math does not lie. The math tells us that we should get 5.98. You notice that we actually got 4.2. So if you put 5.98 on the bottom here times 100, then I believe our percent yield is going to be 75.25%. So not bad. Okay, also on this quiz is going to be a couple of conversions. So let's look at some other problems here and let's do some conversions. This one, letter A, starts with this many grams of iron oxide. It wants to know the number of moles. So we always start with this number, right? This is what we want. So let's think about what numbers in our recipe we are interested in. We are interested in iron, which is here, and we're starting with iron oxide, which is here. So right now, we don't care about the other two things. So let's write down what we're starting with, 34.7 grams of iron oxide. If we are in grams, you want to get rid of it. So you got to put it on the bottom so you can divide it away. You get grams from the periodic table. So for every one of these compounds, it's going to weigh 159.7 grams. Now that we are in moles, we can use our recipe right here. The numbers from your recipe have to be in the same fraction and you only use them once. So think about what you start with and what you want. I want iron. So the number 2 has to go on top. This is what I want. What I don't want is iron oxide. The number here is the number 1. So this is going to be moles of iron oxide. Right? It doesn't want grams, it wants moles, so that means we're going to stop and end here. If you do the math, I believe you're going to get 0.43 moles of iron. Okay? So one more problem down here. This one I'll do in blue. This is what I'm starting with. This is my start. Okay, it wants grams of iron metal. This is what I want. I want iron. Okay, so I'm going to erase this stuff up here so I can do everything in blue. I want iron, so this is my goal. I'm starting with carbon monoxide, so I'm going from here to there. And I have to end in grams. All right, so I'm starting and ending in grams, so that means you should know that it's going to be a long problem. All right, so let's start with 150 grams of carbon monoxide. I have to get rid of carbon, or the grams of carbon monoxide, because I can't use my recipe in grams. If you add carbon and oxygen, you should get 28.01. So one of those compounds weigh that much. Then you're going to multiply by the ratio found in your recipe. So you use the numbers from your recipe exactly one time, and they must be in the same fraction. So the numbers I want to use is going to be the 2 and the 3. What I want is iron. So the number 2 has to go on top. So 2 moles of iron for every 3 moles of carbon monoxide. Now I can't stop here because I want to get to grams. Because I want to get to grams, I have to do one more conversion. I am going to write for every 1 mole of iron, it weighs 55.85 grams. So now I have my full conversion. I should be able to get the answer, which I believe is 199.39 grams of iron. All right, good luck on your quiz.